Hey everyone, my name is Dave Nelson, and I'm here to show you a quick little demonstration video of the Ambience tool I made in Unity for the upcoming VR game Life of Lon. And I covered this in the blog post, but I wanted to just touch on the reason behind this. In this game, which takes place largely underwater, most of it actually is underwater, I really wanted the water to feel like um, you were really there. You were in an environment. Water is not a static thing. It doesn't just sit there and do nothing. It as you go around, as you move, as you enter a current, let's say, or you go near under a waterfall, or you're near something that's moving, the water gets disturbed, and you'll hear that, and you'll hear the effect of the disturbance on the water. And I really wanted to convey that, because originally I had kind of a static backdrop, and it just wasn't doing it. As you're running around, it just wasn't really kind of giving you the experience of being underwater and being near objects. So that's kind of what I really wanted to do is take it up a notch, and especially in VR, I think it's so important that every layer of everything be focused on immersion, the player experience of immersion. And there's no throwaways really. VR, it's got to be everything full on all the time. So that's what I was trying to do with this. So it's a subtle effect, but I think it's really going to kind of up the level of immersion the player experiences. So, without further ado, let's dive in. Real quick, I'll cover some terminology and this sort of test scene. This is just a test container for me that I whipped up. So, don't take it too seriously. We have, of course, our giant levitating fan, which you need in any test container. We have a nice tunnel here that wraps around at the entrance here, and then we have two little particle bubble jet things. So pretend those are one of those ocean vents. We'll call them that. So as a sound designer, I'd look at this and I think, well, obviously they're going to be the positional effects, which will be added on top. As that's sort of the icing on the cake, the geyser sounds of that and the big mechanical sound of the fan. Those are going to be really fun to do, and especially put in 3D sound, around your head, binaural. But again, I'm focused on what's the water doing. What is the water doing, and how is that infecting your environment? And so I'm thinking, well, obviously this fan's going to stir up some water. So we're going to want this whole area that we're in right here to be pretty turbulent. It's got a big levitating, rotating death fan, in there. So we want to make sure that that's conveyed. And then as you stand next to these fins, I want them to kind of make that whoosh whoosh sound, and not in the positional sense necessarily. And I want it to affect the water, and maybe also have a cool positional sound effect, if this were really in the game. But I want it to really stir up the water and give you that sense that that's what's happening. And then we have this tunnel leading up to the fan, which I'm at the end of. But I'm thinking, if that fan's at the end of a large tunnel, and the player were heading down that tunnel not knowing what was there, and maybe they're going down it and feeling a pull, and they're kind of caught in a current, and they're getting sucked toward it, and at some point they go, oh no, I don't want to go toward the giant levitating fan of death, I want to get out of here, and they can't. I also want to kind of ramp up the sound of the water around them, so they get the sense that there's something there, there's something that's pulling them, not just like, oh, I'm getting pulled by an invisible force. So by the time they see the death fan, then they know exactly what's going on. So that's what I would do also. So this tool helps me accomplish those goals. So real quick, terminology. I have this tool is divided into only a few parts. I have the Ambience Controller, which contains the emitters, and that does most of the logic for determining what the sound effect should end up. The emitters are simply AK ambient objects. We're using Wwise for this project, which is fantastic audio middleware. It's a great sound engine, and that's what allows me to do what I'm doing here. So anybody who hasn't tried it, I'd recommend you download it. It is free, at least their demo trial version, so you can definitely give it a shot. So with this AK Ambient, we're just playing the backdrop. The backdrop in Wwise is just a blend container. If you've used Wwise, you'd be familiar with this. It's just it's 4 different sort of levels of turbulent water ambience layered on top of each other and controlled by a turbulence game sync. So as we move it in Wwise, you can kind of see what happens. There. So that's kind of what I'm going for in the game. As we ramp up the turbulence, the water sounds more turbulent. So how we do this is we add the Ambience Controller, which in the prefab here I already have an emitter. I already have all that set up. all we need to do in the Ambience Controller is drag. I need to drag our player in there. That's our listener. There's our emitter. We have the game sync. That is the actual parameter in wise. You have to specify a string literal here. So that is going to control that. So it has to be actually right, correct and wise. We have pitch and volume. That's another parameter I have in here. They can be viewed here. Pitch and volume and turbulence. And those are controlling two different things. Turbulence is what I showed you with the blend. Pitch and volume is simply just a slight pitch and volume boost, which we're going to use for like the whooshing fins. It sounds better than jacking up the turbulence. And also I have a pretty slow slew rate on the turbulence, so it's a kind of a smooth transition between turbulence levels. So I didn't want to raise that, so I have the pitch and volume I can kind of make a more drastic sort of effects with. So with those two parameters, we can get to work on this, and we're going to drag in a group. A group contains zones, and the reason it's called a group is because you can have multiple zones within it, and the zones are actually controlling the area that the sound is being affected in. So that sounds confusing, so I'm just going to show you. Here's our group. We'll just leave it at the origin, which it's not at. So we'll just leave it there. And here's our first zone. We're going to rename the group, actually, bubbles. So those are for our bubble jets here. And we can see them here. And we're going to take this zone, and it is a sphere. And we're going to increase it. You could drag X, Y, or Z. It's sort of like a sphere collider. And in fact, that's what it does. It generates a sphere collider when you start the game based on this gizmo. So I'm going to drag it over that bubble stream. And again, groups, they can have more than one zone. That's kind of the point. And we can add one here. So we have now two bubble streams, each with the zone on them. The group is affecting turbulence. Gotta make sure to check that. I forget that all the time. And is affecting the turbulence emitter. And in that emitter were two of these parameters, turbulence and pitch and volume. If I were to change this emitter name, this is where that name is in that drop-down list. So I can call it turbulence 2, and you can see it changes over here. So we have turbulence 2 now. So that's an arbitrary name. You can call it whatever. And here is the intensity that it affects it. This is what it gives it. And every parameter I'm personally going to use in Wise is going to be between 0 and 100. That just makes the most sense, and that's how I made this tool. So we're going to set it at, say, 40. What we can do is each zone can have a taper, which is just a taper from center. We'll say a linear taper, so at the edge it's 0 and at 0%, and at the middle it's 100%. 100% of this value here, the intensity. And for this one, we're going to do a linear taper too. So it's nice and smooth out toward the edges, and in the middle it's pretty focused. So I'll crank it down a little more, and this should work. There we go. I kind of flew into it, so it's kind of drastic, but you'll see. Pretty smooth. So again, there will be positional audio for these bubble jets to give them that sort of, the real effect, but I also want the water to be stirred up by them. So kind of cool there. Now we're going to go over to the machine. For the machine, I'm going to add another group. And this is just going to have one zone, because what I want to do is I want to make this circular sort of cavern here, this area, I want that to be pretty turbulent, because that's what that machine would do. So I'm going to call this the cavern. I don't know, sure, why not? Cavern. And there's our zone. We're going to leave it spherical, make it larger, and there we go. You can kind of jack it up. We're going to move it over. There we go. That fills that in nicely. So as far as a taper, what we're going to do, instead of linear, because that's really weighted toward the center, we're going to choose exponential or more exponential. Very scientific, I know. But what those mean is exponential is more like inverse exponential. It's higher toward the middle and ramps off quickly at the edge. More exponential just does that more. So it's a very quick taper up, and then it sort of evens out and gives you a large area at the given at the desired intensity here. So we're just gonna kind of put that at like 60, and that's not gonna work because I didn't do that. So we'll go over here and see what that does. Hey, look at that. All right. Look at that. So now in that area, it's a little more turbulent. So the next thing we're going to do is we're going to add a Emission Snake, fancy terminology here, for this cavern. Because what I want to do is I want this cavern, when you enter over here, it ramps up and it ends at this value. So normally, in an emission point, if you made just something directional and with a spherical sort of emission curve or a taper, whatever you want to call it, normally like Unity stuff or Wise stuff, where you can say, hey, however far you are from this object, that's how intense it is. Well, then here that would be kind of useless, because you could hear it through the wall, which I don't want, and then the intensity would be less here than it is here, but that makes no sense. It should be less here and go gradually. So that's why I made this snake, which is basically just a way to make a long line that increases from 0 to 100%. So again, easier seen than explained. So I'm just going to throw that in here. And we're going to call this the tunnel. It's our group. It has a zone. This zone is going to be a box. So we're going to move it around and make it large this way. That worked out, right? Sure, why not? Do that and do that. I'm just going to cover the whole thing. You should be kind of broad with it. The snake is technically an emission point. It inherits from the emission point class. And what emission point is you can have 100 zones chained together in the craziest shape you want. But you add an emission point, and if I add one to here, all you do is throw it in a group, and all of a sudden you cannot hear anything outside of this sphere. There's this sphere here, and that now controls the group. So if you're over here in this zone, it doesn't matter. You're not going to hear anything. And that taper is controlled by this. You could have, again, no taper, linear, exponential, more exponential. So that overrides all the location information in those zones, and then says this is where you're going to hear sound. And of course, based on what the zones are doing in there, that's where you hear it. So it's a way to kind of like, take a more complex shape and make it useful. So we'll get rid of that. We don't want that, because a spherical, like I said, spherical emission is kind of useless. We'll drag our snake in there, which acts the same way, except it's got a cooler name. So the snake is made up of segments. So we're going to go to the start segment and put the start segment at the beginning of our tunnel. And I'm going to turn off this gizmo and I make sure I check that. So go to the start segment. That's where we'll start the climb and intensity. And we're going to move this guy over. And you can just sort of use these cylinders to duplicate that. You duplicate it, drag it out. I'll do that, duplicate that, drag it, duplicate that, drag it. And this is what we're going to do. And just kind of fill out the tunnel with this snake. And that is all you need to do. I'm going to raise the Y a little bit so it's kind of player height. And that's it. Now we put our gizmos back on, and you can see when you're inside this snake, it is being affected. If you're at the beginning, it's going to be 0% of this group value. So that's always going to be the 100% value. So it's 0% here. It ramps up smoothly until it hits here. All the little cracks here, you'll notice, those are all filled in code. That's not, those are accounted for. So you're not going to hear the sound die there. It's really kind of a smooth thing here. So yeah, that's all. Let's try it. One quick thing also, you can take the start percent. Right now it's at 0, so it starts at just 0. If you move it up to 50, it starts at 50% of whatever the maximum is, the maximum being defined by the group. So it's all kind of lots of options, but you kind of need them to make it realistic. So you'll see not in Snake, debugging down here. This is my little helper to tell me, hey, it's working. You'll see the value down there climb up slowly. Hit 100 and then kind of stop. So yeah, it worked really well. Obviously, the value here was higher than the end-up value, but that's easy. That just takes, you always got to tweak everything, make this a little less, and it ends up working out really well. So now you go down the tunnel, and all of a sudden you've hit this area, and hey, look, you're at the death fan, and they knew it was coming because you saw them go down the tunnel. So it works really well, and I'm going to use that a lot in this game because if you're underwater in a current, You might want to enter the current at the side. I can make this shaped as the current, and you enter into it. And I could also set a taper for these cylinders. So you enter, and it's nothing here and full on in the middle. And I can make this sort of wavy current underwater. And instead of just relying on a particle effect, when you're in that current, you'll actually feel the water become more intense, and you'll know I'm in a current. So now you're being moved, you're seeing the particles, and you're hearing the water go. And to me, that ups the immersion. That's a whole another level. You get to add another sort of layer of immersion into it, which is great. So what I'm going to do is, in the interest of time, I'm going to skip to the populated scene I have here. I'm not going to save that. And here it is. Hey, I use different colors. So this is essentially the same thing I just showed you, except I've now done the fan here. And to touch on that real quick, I have there's 4 blades here, and those blades this is a child of the actual machine. And the fins, I call them, are set to control pitch and volume, not turbulence. So they're controlling a different parameter. That parameter has a much faster slew rate and sounds more natural when you're doing stuff like this. So now as the fins pass by, you'll feel the sort of ramp up in sound real quick. So in that, you can see also there is this cylinder here. That is just an emission point. That means those zones, just those 4 fins are tapering out from the middle. And I'm using more exponential. So as you get toward the end of them, they're going down pretty drastically. So I could have used a spherical taper too, but that one seemed to make more sense. So we're going to play it. Here we are in our quote-unquote finished scene. Get a little kick from those guys. Hey, look, a tunnel. Let's go in. What's the worst that could happen? Uh-oh, someone's coming. Oh no, a fan! So now we should get a little buffeting effect from the fins, or the blades, whatever you want to call them. Yeah, there we go. So you can see the environment has, sort of changed around that thing, and you get a real sense that you're around a moving object, that those blades are right there in your face. And you need to consider also that this is without positional audio. Add that on top, and then we're gonna add better visuals, and also playing it in VR, and it really is gonna have a level of immersion I think that's gonna be great, because really what this is doing more than anything is, instead of hearing the objects in the world, you're hearing their effect on the world. You're hearing their effect on the environment. So you're hearing the fan's effect on the water around you. And then on top of that, you're going to, when I get a fan sound effect, I put it on there, put the blade sound effect on there, put all the bubble sound effects, all that stuff, again, icing on the cake, but I want to hear how the world is reacting to the objects in the world. So that's what I'm trying to do with this. I hope you guys enjoyed it, and I hope you guys got something out of it. And thanks for watching. If you have any questions or comments, feel free to drop us a line on the blog or email us, and we hope to hear from you soon.